Hi, today we're looking at Skyscrapers, which is a logic puzzle with a bit of a difference. It requires us to think in 3 dimensions, even though we are actually playing on a 2-dimensional grid. This is a 4x4 grid, and the objective, as is so often the case with these kinds of puzzles, is to fill in the squares with the numbers from 1 to the size of the grid, so in this case 1 to 4. We cannot repeat any digit within a row or column, and we have clue numbers on the outside that tell us how we need to fill in the squares. Now, the squares on this grid represent building plots on a city block. The grid can be thought of as a city block, and the numbers tell you how many buildings you could see if you were standing in that position. So, for example, this 2 here means that if we were looking this way, we could only see 2 buildings. So that would be the case because the numbers that we write into the squares represent the number of floors of each building. If we wrote in a 2 here, then we're saying that that is a building that is 2 stories high. And if we put in a 3, then we're saying it's a 3-story building. To help visualize how that works, we give a look at the solution for this puzzle. So here it is. This is the solution. Don't worry, we're going to do another puzzle in a moment. We're going to work through it from start to finish. This is just to help understand how the puzzle works. So if we're standing here looking that way, that corresponds to standing at the bottom here, looking that way on this grid. So if we tip this grid up, this is solution to the puzzle. If we took it up, you can see that actually we've put in the solution here. This is a 2-story building. This red one is a 1-story, the green one, the 4-story here, at the back there, that's this 3-story. So if we keep tipping it up so that we're standing here looking that way, you can see that we can only see the 2 and the 4-story buildings. The 1 is hidden between them and the 3 is hidden at the back. So that's what we mean by that. We can tip this round sideways and you can see these floors correspond to these floors here. Going the same going this way. So that's the objective. Let's look at how we actually solve one of these puzzles now. We're going to start with this one. It's an easy 1-star puzzle, slightly larger. This is a 5x5, so we're looking to fit in numbers 1 to 5. And as always, we're going to begin by looking for the quick wins. And there's always a quick win, or very often a quick win, particularly on easy level puzzles like this level 1. And that is to look for any 1s on as clue numbers. Because if we see a 1 like this, then we know that we must put the highest number in the cell immediately adjacent to that. If we're standing here looking that way, and then we've got a 1 here, it's telling us we can only see 1 building. Has to be the tallest building, doesn't it? It has to be masking all the other buildings behind it. So whatever's in here has to be masking all of these. 5x5 grid. So this cell must be a 5. And indeed, we've got a few ones here. So we can fill all of those straight in like that because they are all masking the buildings behind them. Filling those 5s in, well, we've got 4 of them and this is a 5x5 grid. So clearly we've got another easy win in that this column and this row are the only ones that do not have a 5 in, meaning that we must have a 5 in this cell here. Now, we're very lucky with this puzzle. We have another easy win. That is this 5 up here. 5 is the largest number on this particular grid. That means we can see 5 buildings. The only way you can see 5 buildings is all the buildings are in the right order from 1 to 5. So we can write those in now as well. So now if we're looking this way, we can see that one and that one and that one and that one and the 5. That's the only way you can do that. Now, I think we use up all of the easy wins on this grid. So what we're going to do now is, well, look, we've got all the 5s, but let's start looking for some 4s because 4s obviously have the most constraints. They're blocking out the next largest number of buildings. So it's usually a good place to start looking. Now, if we look in this column, for example, we know we need to put a 4 in here somewhere. We can't put it in this cell because we need to be able to see 3 buildings standing there. If we put our 4 in here, we would only be able to see the 4 and the 5, which means that we could not fulfill our criteria 3. So that can't be the 4 there. This certainly can't be the 4 because we've got 1 here. Could we put a 4 here? Well, it wouldn't stop us from fulfilling the 3 here, but it would stop us from fulfilling our 3 here. If we put a 4 there, we'd only see that 4 and that 5, which means that this 3 would be no-go. So in fact, the only place that we can put a 4 into this column is up here. Now that's left us with 2 empty cells up here. What I'm going to do, probably not necessary on a simple puzzle like this, but using standard Sudoku notation, we can note that in this row, we're only missing a 2 and a 3. Let's write those in as candidate numbers. Write them in small like that. You never know when they're going to come in handy. Now I'm going to look at this 4 here because we've got a 5 here. We need to see 4 cells, which means we need to be able to see the contents of all of those. And in theory, that could be 1, 2, 3, 1, 3, 4. There's various different ways we could do that, except that we know that this has to be a 2 or a 3. If we put a 3 here, then we're out of options for these 2 cells. So in fact, the fact that we know this is a 2 or a 3 means that it must be a 2, so that this one can be a 3 and this one can be a 4. That's the only way that we can meet our requirement to be able to see 4 buildings. So if we make that to 2, 3 and 4, that fulfills our 4 there. We can now see 4 buildings here. And because we've made that a 2, we know that this one must be the 3. Which means we've completed a row. Let's have a look at this row because we've only got 2 empty cells on here. This 4, well, that's going to make it easy to fill in, isn't it? We're missing a 1 and a 4 in this row. If we put our 4 here, then we're only going to see the 4 and the 5. So that doesn't work for this 4, does it? The 4 must go here, leaving the 1 in here. Now, if we look in this way, we can see a 1, 2, 4 and 5. Without these 2 empty cells, we can put candidate numbers in there. We know that it's a 1 or a 2, isn't it? And more we're at it, we can see that, in fact, now that we've got 1, 2, 3, 4 4s, we're missing a 4 in this column and a 4 in this row. So good old logic tells us that must be a 4. So we might as well write that one in as well, which leaves just a single empty cell here. So that must be our 2. We can see that putting that 2 fulfills our 3 here because we can see the 2, the 4 and the 5 from there. And the same here, we can see our 4 and 5. So just keeping an eye on things, making sure that we're meeting the criteria for the clue numbers. Now, if we have a look at this column here, we can already see, if we're standing here, we can look in that way, we can see the 4 and the 5. We only need to see 3 buildings. So we're going to have to put the 3 in here to block these 2 out, aren't we? Put that in now. And now we've got 1, 2, 3, 4 3s. So we're missing a 3 in this column and we're missing a 3 in this row. So this must be a 3. So we know we've got a 1 going in here. And putting the 1 in here, well, we had a 1, 2 candidate number in here. So we know that this must be the 2. And we also know that it must be the 2 because it's the only number missing from the column. So that's a 2, making this cell a 1. Which means we're only missing these 2 down here, which are easy to work out. We're now at 1, 3, 4, and 5. So that's our 2. And we're just missing a 1 down here. And that's it. We've completed that puzzle. So again, that's a nice, simple, easy 1-star puzzle. Very simple to solve. I use some candidate numbers. You don't really need them on an easy one like this. But as the puzzles get much larger, on the harder puzzles, you'll find rows or columns without without clue numbers as well, which makes things more difficult. And in that case, candidate numbers can definitely be a great help. If you want to have a go at this yourself, then there's a link in the description to download our toaster puzzles. We put these into Puzzle Weekly occasionally as well. That's free. If you want to try this puzzle, then that's from Puzzle Weekly Presents, which has got 120 of these puzzles in, spread over 7 different levels. And there's a link in the description to that as well.
Hello, I'm Auntie. Don't forget you can get our Puzzle Weekly magazine delivered to you every Monday, completely free. Visit the link to get your copy.